Hello everyone, welcome to the next lecture on the CSR UGC NET Mathematics. Today we will discuss about questions related to the real analysis which was asked in the December 2017 paper. We will describe the part B and the part C questions with the help of the shortcut tricks. Myself Dr. Garg, you can simply follow my YouTube channel Dr. Harish Garg. Otherwise you can simply scan and join my WhatsApp group Get CSR Mathematics. What you will be found on my YouTube channel, you can see this is my YouTube channel where you can find the previous MCQ questions of the linear algebra, PY questions on the differential equations, integral equations, all you can find from the year 2011 to 2023. Moreover, you can also find some questions related to the optimization techniques, statistic solution, all are available in the playlist CSR UGC NET. Now let's start with this video. So remember, whenever there is a question related to the real analysis, your target is to discard the options instead of proving the options. So now how you can solve this first question? What is that? They are talking about the 1, 1, on 2 and so on. So what is given to you? F is the mapping from here and it is defined like of this. 2 raised to power m, 2n plus 1. So what is the meaning of the 1, 1 and on 2? So if I say there are the two mapping A to B, it is defined by F. Then each F element of this has its image on here and same for the other sides for the on 2. So look at that. The Z positive, that is it consists of the 0, 1, 2 and so on elements, and Z also. Z is the positive plus minus 1, plus minus 2 and so on. So this is the Cartesian product. So Cartesian product means it's a pair of 0, 1, 0, minus 1 and so on. Right hand side, that is the pairs of the plus minus 1, plus minus 2, 0 and then so on. So now what is that? Clearly says that 2 raised to power m is always with an even function. This is an odd function for all the pairs of the m and n. So what is the for the 1, 1? How you prove that it's a 1, 1? If I simply take two element as of this, then what is the meaning of that? 2 raised to power m1, 2n1 plus 1 is of this. Now there is no need to solve it further. It is clearly say that this is the even and this is always odd, this is always even. So it's happen only when this will hold. Even must be the even, odd must be the odd. What is the meaning of that? m1 is m2. Similarly, when you solve this, n1 is n2. So what is the meaning of that? It is my 1, 1. So fourth option is cancelled out. It's not 1, 1. This option is cancelled out. Now to check whether it's a 1, it's a on 2 or not. If I simply take m is my 0, what is the meaning of that? 0, n, 2 raised to power 0 is 1. So it will give you all the odd numbers. When you take m is 1, it will give you 2 raised to power 1, 2n plus 1. It is always be the even function. Fine. So if you take any of the numbers from here, it will give. But can the function m, n will give you a 0 because it has a 0 element also be there. For what value of the m, for what value of the n, it gives you a 0. Clearly say that this number will never be a 0. This number will never be a 0. So what is the meaning of that? If 0 belongs to the z here, then there does not exist any of the m or n pair which belongs to here. What is the meaning of that? It means this is not onto. So it means the first as this 1, 1 but not onto is the correct option. This is the false option. Okay, now look at the sequence which is defined like of here. This is given to you such that whenever n is greater than or equal to 1, then which of the following is convergent or divergent? That's very simple. Your target is to discard the option. So choose any of the sequence. Choose any of the sequence which satisfied this condition. So that's very simple. If I simply take an is n, so then what is the meaning of that? N plus 1 is greater than of the n plus 1. It's satisfied as equality. So this is there. Now clearly says that this is unbounded. So but here the second option is a bounded. This is a cancel out. If you look about the first option, this is 1 by n square, which is a convergent by using the p test. So this is the convergent, but this option is cancelled out. This is a convergent, this is a correct option. 1 by n is a divergent by using the P series test. Whenever it is less than 1, it is a divergent. So this option also cancels. So third option is the correct option. Okay, look at this one. So let D is the subset of the real line. Consider this statement: every infinite sequence in D has a subsequence which converges to the D. So I think you must remember this, one of the most famous theorem called as the Bolzano-Weierstrass Theorem. What is this statement says? It states if every infinite sequence here, then it implies it is compact. This implies D is compact. So what is the meaning of the compact? It means it is my closed and bounded. That's the meaning of the compact, closed plus bounded. So this set is open set, it is cancelled out. This is closed, it is the right option. It is a semi-open, semi-closed, cancelled, it is not a closed. Right answer is my B. All. That's a very straightforward result. Okay, look at this one. So F is the mapping from 0 to infinity to R is my uniform continuous. So what is the meaning of that? If F is my uniform continuous, it means F is my continuous as well. So what is the meaning of the continuous? It means if it is continuous on the interval here. What is the meaning of that? Whenever the function is continuous, then limit 0 positive, that is whatever the inside portion, always exist. That's the meaning of the continuous. What is the meaning of the continuous? If the function is continuous in this interval, then the limit exists at each point inside this interval. So 0 positive is inside this point. So f dash exists, that is a correct, need not be exist. This option is cancelled, this option is cancelled. Now you have to check about the upper limit. So we can simply take the counter example. Clearly says f of x is my uniform continuous, but if you take the limit x approaches infinity of the f is infinity, it means it's not exist. So it means the first option is cancelled. Right answer is my B is my correct option. Okay, look at this option. So what is given to you? For there exists epsilon such that here the what is a function is there. Okay, so you must remember the definition of the continuous, uniform continuous, bounded, and here. Remember, there is only one correct option. So if I say, assume, if f is my uniform continuous, if I assume the B option is correct one, what is the meaning of that? F is continuous as well. So it means if this option is correct, this option will automatically be correct. But there is only one correct option, so definitely this option is cancelled out. But this is the one method. Otherwise, how you can check whether this is the correct or wrong? What is the definition of the uniform continuous? There exists epsilon. But for the uniform continuous, the definition is for every epsilon greater than 0. Remember, for every epsilon, whenever this condition holds, then only it is a uniform continuous. But there exists, so it means this condition does not hold. Now, so what is the mapping is R to R. That's very simple. You can construct any of the function. Let's say this is a point 1, 0, and x belongs to the any of the subset, say S, where S is the subset of the R, or you can say S is my Q, any subset of, and it is when x does not belong to the S. Then what is the my fx minus fy whenever it is belong? So what is that? It is either the 0 when both are there, otherwise it is 0.1. I consider this as the epsilon. So if I take epsilon is say any of the number which is here, say 0.2. If I take epsilon is 0.2, then x minus is again delta. So what is the meaning of that? This means f is my continuous, but here the function is discontinuous. Clearly says that the function is discontinuous. So this is cancelled out, although this definition satisfied. Also, moreover, you can see that this is a constant or bounded. Clearly say that f is not constant. So this option is also cancelled out. Right answer is only C is my correct option, because you can clearly see that this is not a constant function. Okay, now look at this important one. So f is a function which is defined from the x to y and some condition is given to you. So you can think about any of the function, but I will tell you the simple rule for there. F is 1 1. F is 1 1. What is the meaning of that? F is 1 1 means corresponding to this, it has each image belongs to here. Fine. So what is the meaning of that? There are certain, if I say y, this is x. So what is the meaning of that? It means cardinality of the y must be greater than or equal to the cardinality of the x. That's the meaning of the 1 1. On the other hand, if I say f is onto, what is the meaning of that? Cardinality of the y is less than or equal to the cardinality of the x. Now for the first part, f is 1 1, this is given to you. There exists a function g such that g is from y to x and f of gy is equal to y. That is wrong statement. Clearly says because cardinality of y is more than of the x, so this is the function of the x and whose cardinality, this is the cardinality of here, which is less than of the y. So not for the all y, because it has some element say y naught whose pre-image is not be there. So this option is cancelled. Look at the f is, this is the B option. If f is onto, that this means this hold. If we define the function from here, then f of gy is y. Now you can see g of y, this is the element of the x. This element belongs to the x and cardinality of the x is more than of the cardinality of y. So that means this condition holds them. So B is my correct option. Again, this is the part B, the only one correct option is there, but how we can discard them? F is injective, that is f is 1 1. So 1 1 means cardinality of y is greater than of the cardinality of the x. F y is my countable, then x is my finite. That is again not true, because x may be either a countable or a finite, but they are talking only on the finite, so this option is also cancelled out. Look at the last option, f is onto, that means this condition holds, cardinality of y is less than of the cardinality of x. X is my uncountable, then that's again the wrong. Then what's the y? Y is either a countable or y is either as a uncountable. So it is a countably finite or countably infinite. So y is always a countably infinite. It's a wrong option. So answer is my B is the correct option. Okay, now look at this another one. Set S is there. You have to find the infimum and the supremum. Okay, so they are talking about the sin x. So this is the value of the sin x. Okay, this is my 0. It is from -1 to here. This is my minus pi, 0. This is my pi. So pi minus pi is my minus 3.14. This is my 3.14. Limit is -1. This is my -1, 0, and this is 3, and say this is my 4. Now your target is to find which is greater than of the 0. So this is the portion. This is the only portion which satisfies this condition. Fine. So what is the interval of this? Interval is my 0 to pi. So what is the meaning of that? Infimum is less than 0. What is the infimum of the s? 0. Supremum of the s is my pi. So first option cancel. Supremum does not exist, cancel out. Supremum is pi, fine. Supremum is not equal to, so right answer is my C. That's a very simple argument. So this is my set S because it's of the greater than 0. Okay, now which of the following is the convergence? So this is very simple. Whenever you are talking about the convergent, we always start from the first test, that is the nth term test. Consider the an, find the limit. If limit does not goes to the 0, then it is a divergent. Remember, we will apply the first this test. For the first case, if I consider an is n square over 2n, this is a 0 by 0 form, sorry, infinity by infinity form. So we can take the derivative 2n ln of 2. Again we can take the derivative, so it is ln 2 square, which goes to the 0, but we need not greater than. So it may or may not be convergent. So we will discard the options. Look at the second option. This is 2 raised to power n over n square. This is a reciprocal of this. So definitely when you take this one, it will goes to the infinity. That means not 0. So this is my divergent. But we need a convergence, so this option is cancelled out. Look about this one. If I take 1 over n ln of n, if I take as n approaches infinity, it goes to the 0, but we are not talking about this. But we can see always, if we see the logarithm series, this is convergent when p is greater than 1, divergent when p is less than equal to 1, 0 less than p less than equal to 1. Here p is my 1, so it is a divergent. Now we can look at the last option also. So 1 over n ln of 1 plus of this. I can write this function as of this also. Fine. So if I take the limit n approaches infinity, what is that? This will my e. So log of e is my 1. So this portion will be 1 over 1, which is not 0. So this is also be a divergent. So the right answer is my here. So which may or may not be. So you can apply the root test or you can apply the ratio test. If I take here, how you can do that? If I take limit n approaches infinity an of 1 by n, that is a root test. So it is here over 2. So what is that? This is 1 over 2, that is 1 by 2, which is less than 1. So it means this is my convergent. Okay, which of the following statement is true? That's very simple. We all know infimum is always be less than of the supremum. Fine. So first option, p less than q, p and q. You can see this option is same. This is already same both sides. So we already know infimum is always less than or equal to the supremum. So it means p is less than q satisfied. Let's say r is less than s. R, so again supremum, both are same. Again infimum is less than of the supremum, r is less than equal to s, that's satisfied. Q less than equal to s. So how you find the q and s? So let's say q and r, infimum, supremums. Okay, so firstly we can say infimum of the amn is less than of the supremum of this. Now if I take supremum here and infimum this, which does not give you any relation between them, so this is not true. P and s, here both are my infimum, both are my supremum, so definitely s is greater than of the p is my correct answer. The second option, q less than r, is wrong because this result is hold, that is this supremum is greater than of the infimum, but here the limits are infimum and supremum. We can't find the relation between them as exactly of less than of this. So that's why the answer are A, C and D are the correct options. Okay, this is the part C. More than one correct options are there. Let R be the set of the real numbers, Q the set of the rational numbers. Then for every this A epsilon is the open interval of 0, 1 minus epsilon. Then which of the following statements are true? Supremum of A epsilon, okay. So what is the infimum of A epsilon? 0. What is the supremum of A epsilon? 1 minus epsilon. Fine. Now we can think about here. So firstly we will think about epsilon. Since epsilon 1 is less than epsilon 2, what is the infimum of A1? Infimum of A epsilon 1, this is a 0, this is also 0, but they are talking about less than, but here it is equality, so this option is cancelled out. Look what the second option, so B option is cancelled out. C, again epsilon 1 is less than epsilon 2, supremum of A epsilon 1, 1 minus epsilon 1, supremum of A epsilon 2, 1 minus epsilon 2. From here we can see 1 minus epsilon 1 is greater than of the 1 minus epsilon 2. That means supremum of this is greater than or equal to supremum of A epsilon 2. But here we can take strictly greater than. So we can write here as a strictly greater than sign. So supremum of A, this is the correct statement. Look about this one. So again one more supremum is there, it is less than 1. Okay, what is that? From here, can you find the 1 minus epsilon? So it is less than epsilon less than 0. Fine. So what is the 1 minus epsilon? Half. 1 minus is 1. So this value which belongs to the half and 1, equality is there. So what is the supremum of this line? What is the supremum of this is less than equal to 1. But they are strictly said it's a less than. So this option is also cancelled. Okay, look what this one. Here, can I write this part as A epsilon intersection R? It's a negative. So A epsilon intersection Q. Or you can see the Q complement. Now that's very simple. If I simply take A epsilon is my A comma B, or R is my real line, then what is this line? Fine. What is the A intersection Q? So A epsilon, that is A comma B intersection Q, and A epsilon Q complement is again A comma Q complement. Fine. Now your target is to find the supremum of this A epsilon. We already find the supremum, whatever is there, the supremum is dependent on the limits. Here the limits are all same. So what is the meaning of that? Supremum of this is equal to the supremum of this is equal to the supremum of this. So both are my correct option because they are independent of this Q or are there. So the right answer is my C and D are my correct option. Okay, so this is a very interesting question. So x plus y is fx fy. So can you think any of the function? Definitely the function is of this form. Function is of this form. Function is of this form. Then only it will happen. Fine. So look at the options are there. So if I take f is my this. Fine. It satisfied this property because it is said this is nothing but ex of ey. That's satisfied here. And limit x approaches 0 is a 1. That's also satisfied. Is it an increasing function? No. So this is a cancel out. F is either constant or bounded. That's again wrong because if I simply take f of x is 3 raised to power x, that is of this form. Again it's satisfied. Is it a constant? No. Is it bounded? No. This is an unbounded function. E raised to power x may be the bounded, but this is an unbounded function. So this option is cancelled. F of xy is here. So if I simply take this function, what is the of this? 3 of rx. So if I can return of this, so what is the 3 raised to power x? Fx of r. So this holds. Even this hold for here also. What is the f of rx is e raised to power minus rx. I can return as e raised to power minus x of r. Fx of r. So this holds. F of x is greater than or equal to 0 for all x in the real line. So if I consider here, we all know this is always be greater than 0. So this satisfied. A raised to power x. So whenever x approaches minus of infinity, this value is greater than or equal to 0. That's also satisfied. E raised to power minus x graph is there. It is always be the positive. So this option is also correct option. So C and D are again my correct option for this case. Okay, now look at this. A very simple problem is there. So whenever the limit of here n over k square n square. So clearly say that this is the question related to the limit of the sum. Whenever there is a question of the limit of the sum, we can change into the integration. How you can change the integration? I can take n square common from the denominator. So I can return like of this. Fine. Now if I take x is my k by n, then what is my dx? 1 by n of dk. So if I substitute here, this is 1 by n of dk, that's a limit changes with respect to k, 1 over 1 plus x square of dx. What are my limits? When k is my 0, what is the value of the x? 0. When k is my n, what is the limit of this is my 1. So what is the answer of this? Tan inverse x. So it's a pi by 4 minus 0 is a pi by 4. Right answer is my D is the correct option. Okay, now look at this 67th. Which of the function is continuous? And here, what is the meaning of the continuous? It's a two variable. We simply prove limit exists. Fine. So firstly, we can take about the first part. We can simply take y is equal to mx path for here. Fine. So what is my f? 1 minus cos 1 plus mx over x square common 1 plus m square. Now we can take the limit as x approaches 0. So what is the 0? So cos 0 1, so it's a 0 by 0. So we can apply the L'Hopital rule. So sine 1 plus mx into 1 plus m divided by 2x 1 plus m square. Fine. Now what you can do, again it's a 0 by 0 form, or otherwise I can multiply by 1 plus m, divide by 1 plus m. So this number, what is that? Whenever you take limit x approach sine x by x, this is a 1, and it is 1 over 2 1 plus m whole square 1 plus m square, which depends on the m. So it means limit. What is the meaning of that? Does the limit exist? Limit does not exist. So once the limit does not exist, it implies function is not continuous at 0, 0. So the first option is cancelled out. Look at the second option. Function is continuous everywhere at apart from the 0, 0. So if you take any of the points, say 1, 1, what is the function value at 1, 1? Half. If I take 0, 1, again the value is half. So which is a constant, which, and every continuous function is every constant is a continuous function. So it is a continuous. Similarly, we can check about the g is continuous or not. Again, we can take the path. We can substitute in the g 1 minus cos 1 plus mx, and it is 1 plus m whole square of the x. Again, it's a 0 by 0 form. When you take x is a 0, we can apply the L'Hopital rule. Sine 1 plus here, and it is 1 plus m whole square. Fine. Now what is the limit of this? It's a, into 1 plus m also. So 1x will be cancelled out. What is that? Sine of ax by here. Is there any wrong? It's a sine. Cos will be the sine. X will be 1 plus m, and it is 1 plus x square. So it's by 2x. So now you can clearly say sine of this, it is my 1. So the answer is, which does not dependent on the m. So it means it is continuous at the point 0, 0. So this is, so once it is continuous 0, 0, again for the second pair, if we take as 1, 1 or any of the pair, the function value will be half, is also be the right answer. So B, C, D are my correct answers of this problem. Okay, look at the last question. So which of the following is the bounded variation? So what is the shortcut tricks for you for the bounded variation? Whenever the function is of this form, cos 1 over x raised to power beta or x raised to power alpha sine x raised to power beta, then it is said to be the bounded variation whenever alpha is greater than of the beta, strictly greater than, remember. So if I compare the first option, 2 is greater than of the 1. So it means yes, it is a bounded variation. You can check for the derivative. So we can find the derivative 2x cos 1 plus x plus x square. It will be the sine. So the derivative of this is a minus. So it's a minus sine 1 by x, and x will be minus 1 by x square. So it is my 2x cos 1 by x, x square will be cancelled, minus minus plus sine 1 by x. Now here you can see it's a 1, it is a 1 which is not satisfied, it is not a bounded variation. Moreover, if I write here as a 0, again 0, and here 1 which is not bounded variation. So it is not bounded variation. So second option is cancelled. Now look at the derivative modulus. What is the f dash is? 2x cos 1 by x plus sine 1 by x. if I take the absolute value, it will be less than or equal to mod of 2x. Cos modulus is less than 1, sin modulus is less than 1. Mod of 2, mod of x is 1. Mod of 2 is my 2. Okay, what is the x? You can see for x in here, the modulus of x is my 1 plus 1, so it is less than equal to 3. That is the fourth option is the right answer. So A and D are my correct options, rest are my wrong. So this is the way you can find all those CSR net December 17 real analysis question in very simple manner. I hope you can simply remember these tips for your coming examinations. I hope you can like, share and comment my videos. Best of luck students. Happy learning.